Okay, so these first few say, and we're not necessarily doing all of them. I just put a bunch of problems on the paper so I'd have something to choose from. Says factor the common factor out of each expression. So what's the little acronym for what it's asking me for? Yes, greatest common factor. And so what letters do we use for that? GCF. So factoring out the GCF, you absolutely positively have to know what that means, how to do it, and never forget to do it. Okay? These things are things that people, even the Algebra 2 teachers are like, they still can't factor out a GCF. Okay? And so you need to be able to do that and understand what it means. The hardest part about calculus is not the calculus. It's the algebra that's involved in it. That's why Algebra 1 is the most important math class you will ever take in your entire life. Okay? And it's important that you have that strong foundation because it's going to continue, and not just in math, but in your science. And I know if you're sitting in chemistry, you're sitting in biology, you're not using a whole heck of a lot of math. You're sitting in chemistry, you're starting to realize, wow, I'm using a lot of math. But it's still not the kind of math that you're necessarily doing in your math classes. That hits you in physics and beyond. And then they kind of become the same. And you finally see like, oh, wow, this stuff is important, right? But if you don't have those strong skills, it's going to make you struggle. So here, can I solve number 1? Can I solve it? Is it an equation? No, because it doesn't have a what? Equal sign. So nobody's asking me to solve for anything. That's the other thing is you got to know what it's asking you for, right? This is an expression because there's no equal sign. I can't solve it. Nobody's asking me to. I'm just looking for the GCF. So it's not that y'all don't know how to factor anything out. It's that you can factor a common factor out. You don't always get the greatest common factor out, right? So what is the largest number that could divide into all 3 of these terms? 5. Now, you want to keep your leading coefficient positive, if at all possible. So I would factor out a -5, right? If all I do is factor out a -5, is that the GCF? No, because there's also variables, right? Right? So with these m's, what's the greatest number of m's I could take out? 1, right? Of each one of them. Like I could take 5 out of here, but 3 out of here, 1 out of here. So I could take 1 out of each one, which means my GCF is -5m. And when you factor out the GCF, it does not disappear. Because what we're doing is we're not changing the value of what we have, we're changing the way it looks. Okay? Just like if I said reduce 4/8, well, it reduces to 1/2. They look different, but they have the same value, right? If this -5m disappears, then I don't have the same value because I can't put it back like it was. So then what I'm left with, right, I divide this, -35 divided by -5 is +7, and then that would be m to the what? 4th, right? And then -5m cubed would give me what? +m squared. And then -20m, when I divide out the -5, I get a +4, and then that's it. When you're done factoring out the GCF, you should be able to distribute it back in and get what you started with. And if it doesn't work out that way, you didn't do it right. Does that make sense? So -5 times 7 is a -35. M times m to the 4th is m to the 5th. So -5m times m squared is a -5m cubed. And then 4 times a -5m gives me the -20m. Does that make sense to you? Easy enough? Okay. So let's look at this one here. No, actually, let's look at it. Let's look at one with 2 variables. We'll do this one. Right. So, looking for the greatest common factor. So do it a piece at a time. The number that I'd want to factor out would probably be a -1, right? So can I factor out a -4? No, because it doesn't divide evenly, right? But I could factor out a 2, right? So I'm going to factor out a -2. All right, what about my x's? How many x's could I take out? Just 1. How many y's? I don't know if you can read my little tiny numbers. 3, right? I can take out 3. So that's my GCF. That goes on the outside. I have my parentheses. So now I do it a piece at a time. -4 divided by -2 is +2. And then x to the 6th divided by x is x to the 5th. And then y what? Squared. Right? Then -10. And I've seen some of you, and I probably should have written it this way. I don't really have room. I guess I can let me rewrite mine. You don't have to, it's not wrong, so you don't have to rewrite it, but what was my GCF? -2y cubed. Okay, so what I've seen some of you do is come in here and do this kind of thing, And that's fine, negative 2xy cubed, because that's technically what you're doing, right? You just have to remember that when you do that, so you can either write that or you don't have to write it. That's like a personal preference, whether or not that makes sense to you. So when you do that, make sure you understand, again, it's not disappearing. It's coming out here. So this gives me the 2x to the 5th y squared, right? Isn't that where we were? Okay. And then the positive 10 divided by negative 2 is negative 5. What happens with the x's? They cancel out. I have no x's left, and so then I have y to the 5th. And then 4 divided by negative 2 is negative 2, and then that's it. Okay, that is factoring out the GCF. That's an important thing to be able to do. We all good with that? Any questions? All right. So I'm going to leave those other two for later. Let's see. Let's look at number 5. Okay, so now here's the couple of things about this. This says solve each equation by factoring. There are other ways to solve it, right? You can solve it with quadratic formula. You can solve it by completing the square. I mean, there's other things that you could do. But this clearly says by factoring, and it says solve, which means when I get to the end, I should have x equals something, right? And with a quadratic, okay, you've got the x, or the squared term being the biggest one. With a quadratic, how many answers can you get? 2. Can you get more than 2 from a quadratic? No. Could you get just 1? Maybe. Could you get 0? Okay, look at this. So if I have a quadratic that looks like this, here are my 2 solutions, right? If I have one that looks like this, I only have 1, right? I only have 1 real solution, is the way I should say it. And then if I have this, because your solutions are where it touches the x-axis, right? So you have 0, 1, and 2 real solutions, because you're going to get into imaginary numbers in Algebra 2. So for the most part, most of the time you're going to get 2. Sometimes you might just get 1, because you get the same thing twice. It's really just one answer. We probably really won't run into this too much in geometry, because if we don't get 1 at all, then it's whatever we're doing doesn't make any sense, because we're trying to find something. That's more of an Algebra 2 thing, but it probably happened to you in Algebra 1. So chances are pretty good we're going to get 2, right? So the first thing you should always do, step 1, unless you are completing the square, you set it equal to 0. And keep your leading coefficient, your squared term, positive, which means I don't want to move this over here. I want to move this. I mean, you can, and then you can multiply through, but we're trying to make things easier. So we're going to take this, and we're going to move it over here. Does that make sense? So this is going to give me a squared plus 10a plus 16 equals 0. And then you put them in order. ax squared plus bx plus c. Everybody good? Now, you take your leading coefficient, whatever's in front of the a squared, which there's nothing there, which means it's a what? 1. Okay. So if it was something else, I'd have to multiply this times the 16 to figure out what I get, right? But since it's just a 1, I'm just looking at the 16. So 16 is my magic number. I need 2 numbers that are going to multiply to give me 16, but combine to give me what? 10, okay? And then you have to decide, are we talking positive, 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 negative, 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 that sort of thing. When all 3 of these are positive, then the 2 numbers have to be what? Positive, okay? Which means I need the 2 factors of 16 would be 1 times 16, 2 times 8, 4 times 4. Is there anything else? Now, here's what you don't want to lose track of, is the 1 times 16 is important here. When we're simplifying the square roots, the 1 doesn't matter, right? But here it does. That could totally be one of my answers. Now, because I don't have to worry about whether it's addition or subtraction because they're both positive, which ones of these sets works, gives me the 2 and the 8, okay? So this is it. Everybody okay with how to figure that out? Okay. So now we're going to factor by grouping, which if your leading coefficient is 1, it's kind of an extra step, but that's okay because it works for everything. And here's where I feel like some of you kind of got to this point and you were ready to do that, and then it was a hot mess after that, right? So what we're going to do is these are what go on the A. So I have a squared, and then I'm splitting up this 10a into plus 2a plus 8a plus 16 equals 0. Don't lose your equals 0. Okay? So this right here, the sign stays with the number. Okay? So this is a positive, so it's just positive, and I can just put my little parentheses here, and I can put them here. And then, here's why you have to be able to factor out a GCF. You are factoring out the GCF of these two sets of numbers, right? So in this first one, of a squared plus 2a, what can I factor out? A. So this is a times a plus 2, right? Parentheses. Plus, what's the GCF over here? 8. So I can factor out the 8, and I'm left with what? A plus 2 equals 0. Now look at what you have. You have another equation that has a GCF. This is one term, and this is one term. Do those two terms have something in common? The a plus 2, right? So when I factor out that a plus 2, I'm left with a plus 2 times a plus 8. And that is the factored form. Equals 0. It's an equation the whole time. Don't lose that. All right? So I have all that. Now, I'm not done. That is fully factored. It doesn't just say factor it. It says solve by factoring. Now, if you need to check yourself, then if you multiply this stuff back together, you need to know how to multiply it back together. And some of you learned the box method. Some of you, anybody, does the word FOIL mean anything to you? Okay. I don't care how you do it, as long as you know how to do it. What I'm going to say is you should FOIL it, and then you just have to know if FOIL means something different to you. It's fine, right? But if I do a times a, I get a squared, right? 2a plus 8a gives me 10a, and 2 times 8 is 16, right? So I can check myself. But I'm not finished, right? I've got to solve it. So you have to use what's called the zero product rule. So let me just ask you this. I'm going to go over here and just do something. Here, I'm going to write this right here, and I'm going to erase it, so don't write it here because it won't make any sense to you. But if I do p times q equals 0, tell me something you know about p and q. One of them has to be 0, right? Because this could be 3 times 0 would equal 0, or it could be 0 times 5, right? But if they multiply together, one of the two of them has to be 0. We agree with that? It's called the zero product rule. All right, so that means that over here, same thing is happening. These two things multiply together to give me 0. I want to know when is it 0, right? It's not always 0, but that's 2 of the points on my parabola. So 2 things could happen. A plus 2 could equal 0, or a plus 8 could equal 0. So you set both of those little things equal to 0, and then you solve them. And here you get a equals negative 2, and a equals negative 8. Which means, and clearly I did not give you nearly enough room to write on all this, a is equal to negative 2, negative 8. Okay, that's your set of answers. Or if you leave it as a equals negative 2, a equals negative 8, that's fine. I'm not worried about set notation and all that kind of stuff right now. It's more about, you've got to be able to factor it. That was on that segments paper. And there's a ton of people that came in and goes, I don't know what to do with this. Said, okay, what kind of equation is it? A quadratic? Okay, then you've got to factor it and solve it, and that's something you have to be able to do inside of other things that we're doing because it's going to keep coming up. Okay, we good? You want to do another one together? Okay, let's do another one together, and then we're going to do some that A is not one. Okay. Because you need to know when this equals 0. That's what I want to know. It doesn't always equal 0 because if these are my two answers, then that means I'm here at negative 2 and I'm here at negative 8, right? And so it looks something like this. I don't know exactly what, how far down it goes or anything, but something like that, right? So I want to know what these 2 points are. I don't care what it is when y is 1 and when y is negative 3. I want to know when y is 0. And since there's 2 answers, either, just like I said, that p times q is 0. So either this one's equal to 0 when that happens, or this one is. So I set them both equal to 0 when that happens. Does that help? Okay, we good? Anything else? All right. So now, let's try this one. So this x squared is already positive. I'm assuming this is probably the best space one to redo. We'll do this one. So I've got x squared, then plus 5x minus 6 equals 0. A is 1, right? So this is 1 right here, so I'm good to just look at this. So I need two numbers that multiply to give me a negative 6, right? And combine to give me that positive 5, right? So it's combine. It's not necessarily add or subtract type of thing. Since this is negative, you get this by multiplying the two numbers together. So that means the signs have to be different. It has to be a positive negative situation. Does that make sense? That's how you know. So my factors of 6 are 1 times 6 and 2 times 3. Right? So which ones am I using? 1 times 6 or 2 times 3? 1 times 6, because it's gonna, the signs have to be different. And when the signs are different here, which one is going to be positive? The 6. So it's a negative 1 and a positive 6. Okay? 2 plus 3 is 5. That's great, but that doesn't get me anywhere. So then I put that over here, and I've got, oops, that gives me x squared minus x. Actually, let me do it different. I'm going to do x squared plus 6x minus x minus 6. Okay. Equals 0. Thank you. Equals 0. Cannot forget the 0. All right, so when you put your parentheses, the sign stays with the number, meaning that when I put this in here, the way we wrote it, this goes here, right? This goes here. But these are not being multiplied together just because I put parentheses there. So I'm adding these two things together, but that negative has to stay on that x. Okay, everybody good? Then I factor out my GCF. What's the GCF in the first one? X, so that leaves me with x plus 6, right? So now when I look at the next one, negative x is what I'm, oh, I lost off my, oh, it's just a negative, sorry. It's not a negative x, it's just a negative, right? It's just a negative 1, because I need this to be positive, so this is I'm going to factor out a negative 1, and that leaves me with x plus 6. And that's why I wanted to order it that way, in case that happens to you that way. So now, these two terms, these are two big terms, have this x plus 6 in common, so I've got x plus 6 times x minus 1 equals 0. Now you solve. Now I heard somebody say while I was doing this, oh, she does it, whatever. I'm not saying this is the only way to do it, all right? If you write it backward, what did I do differently because it was bothering somebody? Tell me. Okay, that's fine. Okay, so what he's saying is he didn't write it out and factor all this stuff out. You just jumped to this point, right? And that's okay. How many of you were taught just to jump here and not do this? Okay, that's okay. That works for this just fine because it kind of seems ridiculous. Like, why are we doing that? I'm about to show you why we're doing that. Because it works if A is not 1 and you can't factor it out. Okay, so we'll do one of those. So now, yes, I'm not done. So I get x plus 6 equals 0. And so that means x equals negative 6 and x minus 1 equals 0, which means x equals 1. Okay, everybody okay with all that? Any questions? Okay. And so here are my two answers, or you can put it as a set, and that's fine. All right, so let's see. Let's do, I just grabbed these problems really quickly, and I feel like they are some of these numbers are way bigger than what I wanted. So we're going to ignore some of these. I'm going to give you one on the back here. So flip over on the back where you have some blank space. Yeah, I gave you the answers so that if whatever we don't do, if you wanted to go back through and see if you can do them, see if you can get the answer. All right, so let me give you this one. Let me give you 3x squared plus 13x minus 10 equals 0. Does this one have a GCF? No, 1 doesn't count. It does not, right? So if it doesn't, and A is not 1, so I can't just look at that negative 10, all right? Here's where the grouping thing is going to come in handy. So I'm not exactly sure how y'all were taught if you didn't do the group. Were you taught the grouping at any point? You never had A not 1? Oh. Okay. Oh, goodness. Okay. All right, so A is not 1. And first of all, if A is not 1, try and factor out the GCF. Sometimes you can factor it out, and then you just work it like the rest of them, and we'll look at one of those too, okay? But A is not 1, so you take these two and you multiply them together, okay? And I'm going to get negative 30. Now, that's the number I need them to multiply to give me, but I still need them to combine to give me the 13, right? Now, this is negative, right? Which means the signs on my two numbers are positive and negative. They're different. So I can have a negative 1 times 30. I could have 30 times a negative 1, whatever. Like I could switch the signs up. So I could do 2 times 15. I could do 3 times 10. I could do 5 times 6. Is that it? Yeah. And then since this is positive, which one's positive? The bigger one or the smaller one? The bigger one. So if I go through here, it would have to look like that, right? So those are my factors. Which one do I use? Negative 2 and 15. The 3 and the 10 are tempting again, right? Because, you know, it's 13. But it's negative 2 and 15 because you can tell by these signs what should be happening with those numbers. We all good? All right, so I'm going to put the negative second again just to kind of make sure that you understand what happens if you write it down that way. So that means I'm going to take this, and I still have 3x squared, but I'm breaking up this 13x. And I'm going to do plus 15x minus 2x minus 10 equals 0. So you can notice right here, I have not changed the value. I have just changed the way it looks. We all good? So this is called factoring by grouping. So I'm going to group them. I group the first two terms together. I group the second two terms together. That sign has to stay there. And these are being added together. This is not a multiplication thing. Because I've seen people get to this point, put the parentheses, and then like foil it, and I don't know what the heck you're doing. Okay, you start making up stuff because it looks like you should do something. Oh, that's what I did. Okay, so now you look at these, and you're going to factor out the GCF. What's the GCF in the first one? 3x. So I take the 3x, and I'm left with x plus 5. Okay. And then the GCF here is negative 2. And when I factor that out, I get x plus 5. You expect for these to match every time. Otherwise, this isn't going to work out too well for you, right? So when I factor out that x plus 5, that leaves me with the 3x minus 2. But do you see how this is addition, this is subtraction, this is multiplication because I am factoring it out, right? And that equals 0. That is factored. That is the easiest way. That is easier than what I did on the video, but I did it that way because that's the way it used to be taught. But grouping works way better. And if you're consistent and you do that even when A is 1, it'll work out better for you, okay? So am I done? No. So now I do x plus 5 equals 0, and 3x minus 2 equals 0. So x equals negative 5, and x equals 2 over 3. Okay, there are my two x's. Is it positive or negative? This is positive because I would add the 2 over here and then divide by 3. Everybody okay with that? We good? I think we need to practice on this. I need to give you better problems to practice with on this than what's on the front, though, because these, I mean, they work, but the numbers get ginormous, and I was just grabbing them quickly, and I shouldn't have done that. But let's go back to the front. I want to look at another one that's a little bit different, too. Oh, what am I doing? Let's look at, like this is one that you would do that on, but you do the 3 times the 48. The number's big, and that still may happen to you, so it would not kill you to do these problems. I'm not saying that they're like super bad. It's just not the good ones to start with when I'm trying to explain something to you. Let's do this one. Let's do number 9. Okay? So I'm on number 9. Just around, jumping around. It's already set equal to 0, but do we like how it is? No. So I'm going to go ahead and move everything to the other side and put it in order. So this is going to give me a positive 3x squared plus 6x minus 9 equals 0. Make sure you're not just moving it to the other side and leaving it the same, right? You don't just get to willy-nilly move stuff and be like, oh, there you go, right? All right, so we're here. So now, does this have a GCF? Yes, it has a GCF, so I want to factor it out before I do 3 times negative 9. Could you factor it that way? Yes, but when you do, you won't be completely factored in the end, and you will think you are, and you are not. Okay, so we factor out the GCF first. So that, what is my GCF? 3. So 3, and then that leaves me with x squared, then what? Plus 2x, then what? Minus 3 equals 0. Now, the 3 does not disappear. You do not get to divide it out. It is still part of the function, and it is still important. It is not going to affect my answer at this point, but you can't get in the habit of dropping it off because that'll hurt you later on in what you're doing. Okay, so now I'm looking for two numbers that multiply to give me a negative 3 and combine to give me a positive 2. So really it's just 1 times 3, and you got to figure out which one's positive. The positive is the 3, the negative is the 1, right? So this is what I'm using. So because A is 1, you don't have to go through all of that. Really the grouping, because the same thing happens every time. What this gives me, you already have your factors. If A is 1, you can just jump to this point and say, okay, that's x minus 1 and x plus 3, and you're done. That extra step in there is not necessary. I mean, it explains mathematically why you get this, and that it's not just magic, but it's not necessary when A is 1. Okay, so if that could kind of help simplify things a little bit for you too. Okay. Does that help? Any questions? Am I done? No. Okay, so here's my factored form, right? This 3 does not affect the x's. However, if your instructions are to completely factor it, this is completely factored. If that 3 is not there, when I multiply this back together, am I going to get this? No, I'm not. I'm going to get this, but that's not the original. So that 3 is still important there. When you go to set them equal to 0, then I get x minus 1 equals 0 and x plus 3 equals 0, and that 3 on the outside doesn't affect this. So I understand you get the same answer, and that's why I think you think that you can, or if you've been doing it and you were sloppy, nobody fixed you. So, right. Well, yeah, I mean, you're not really dropping it off. You're just using these pieces here. And then x equals negative 3. Everybody okay with that? Anybody confused by the fact that you can just take this and jump to this point? Because I know y'all learned it different ways. If you learned it a different way and now it makes sense to you and you want to do it that way, that's okay. Just like foiling it. Some people learn distribution. Some people learn the box. There's other ways to do it, and that's okay. I'm not trying to change the way you did something unless you don't know how to do it. Okay? Any questions about any of this? Yes, sir. Well, nothing. It's just like if this was 3 times P times Q equals 0, then still, it's either P or Q have to be 0. So that's what I'm trying to figure out. He's just hanging out over there, not doing anything. Okay? Has to stay outside. Yeah, exactly. All right, one more, because we got time. Let's say that we have 4x squared minus 12x equals 0. Is that a quadratic? Yes, because it has that x squared term, right? Does it have a GCF? Yes. What is it? The GCF. No, a common factor is 4. The greatest common factor is 4x. See the difference? That's what y'all are bad at. You can factor out a common factor. Greatest common factor, the most I could possibly take out, it is 4x. That leaves me with x minus 3. How many solutions do I get here? No. 2. This is still P times Q, right? Either this part is 0 or this part is 0. So I set 4x equal to 0 and x minus 3 equal to 0, right? So my x's are 0 and 3. So it looks like this. here, and here. 0 is still important. Okay? Does that make sense to you? You do not get to, if I divided both sides, if I just divided it all out and that disappeared, I'd only have 1, I wouldn't have 2. Does that make sense? Okay. The other problems on that paper are doable. They're not that horrible. The answers are on the back. I suggest you practice and try, okay? Have a great day. I will see some of you later.